Oh, I jumped the gun a little bit on section 2.1. We're not quite done. I just peeked at your homework and realized that there are a couple other details. The first one is that I just forgot to point out something that I had written here. When we group data, it's a trade-off. We lose information about individual values, but we gain a more compact representation. What does that mean? Let's take a look at this, at the grouped data that we came up with for this list here. Okay, so I think you'll agree that this table is more compact than this whole list of 100 numbers. That's what's nice about it. We can summarize it with just like 6 categories. The trade-off is that we have now lost information about the individual numbers in the list. So for example, when we look at the original list of numbers, we can see that there's a 12 in it. But when we look at this summary, we can't tell that anymore. We can only see that there are some numbers from 0 to 20, but are they 12s? Are they 10s, 9s, 13s, 18s? We don't know anymore. We have lost that information. So there is going to be some homework question that asks you something about that, and that's basically what they're getting at here. If you only know that numbers range from 0 to 20, you can't reconstruct what those numbers actually are. Okay, and then another homework question asks us about summaries on this grouped table, and they are called class limits, class width, class midpoints, and class boundaries. I'm going to refer you to page 45 of your textbook. There is a definition box there that lays these all out for you in the current edition anyway, that's on page 45. I think that's the 14th edition this year. But let's just discuss them together. Okay, class limits. The class limits are simply the smallest and largest numbers in each class. In this class, the lower class limit is 0, and the upper class limit is 20. The class width is the difference between one lower class limit and the next lower class limit. So it would be, for example, 20 minus 0, which is 0. 20 minus 0, which is 20. Or 60 minus 40, which is 20. Since these classes should all have the same width, you should be able to subtract any consecutive pair. 80 minus 60, 120 minus 100, if you want to subtract the upper class limits, but the difference will always be 20. Class midpoints. Okay, so the midpoint would be the average of the two class limits. So for this class, we've got a 0 and a 20. The average of 0 and 20 is 10. It's the point halfway in between. So you can either think about that as a midpoint on the number line, or you can actually plug these numbers into your average formula, where you can add 0 plus 20 together and then divide by 2. So this class would have a class midpoint of 30. And then the final one is called class boundaries, and I can see that actually won't apply to this example because these classes touch each other. I'll have to create a new example to illustrate this one. All right, here's the new example I've come up with to discuss class boundaries. Let's suppose that we're looking at a student grade distribution. This is something that you and I have to worry about every semester. So in this class, for example, if you score 90 to 100% for your class average, you'll get an A. 80 to 89% will be a B, C, D, and F. And again, I'm going to avoid open-ended classes. So instead of saying below 59, I'm just going to assume that the lowest score in this class is 50. So I'll call that class 50 to 59. So the difference between this example and the last one is that now this upper boundary of 59 is not exactly the same as this lower boundary of 60. There's a gap between them. And that's because these are rounded to the nearest whole number. So a class boundary would be involved if there was a student who was right on the edge between, let's say, a B and an A, And the question would be, how do we know if that student should be classified as a B student or an A student? How do we know if his grade is closer to an 89 or a 90? We have to look at the halfway point between them. So the class boundaries are basically the average of one upper class and the next, one upper limit and the next lower limit. And normally these are going to be just 1 unit apart. So the class boundary will be a halfway point. So 59.5 would be the class boundary between the F students and the D students. If someone scores below 59.5, he would round down into the 50s and be an F student. But if somebody was above 59.5, she would round up to a 60 for a D. Okay, so what would be the class boundary between the D category and the C category? I think you could see it's pretty easy. That would be 69.5. And then these would continue to increase by 10, which, by the way, is the class width, because remember, 60 minus 50 is 10, 89 minus 79 is 10. You can choose any two classes and subtract either their lower or upper limits. That'll give you your class width. And it should be no surprise that the class boundaries are also spaced apart by that same width. If you really want to be nitpicky about it, and some of the homework questions are, you could also say that the lowest class boundary is a 49.5, because you can kind of think about this as being a span of numbers that technically would range from 49.5 to 59.5 before they're rounded. And then the highest boundary would be 100.5, because that would be the cutoff before getting to 101, which doesn't exist here. But if you're rounding, basically 90 to 100 means really it would include any number that is between 89.5 and 100.5. So sometimes you'll even see these silly super boundaries involved in homework questions. Okay, and I do believe that does cover all the bases for section 2.1. So let's move on now.